Hello, good morning everyone. Today I would like to teach you on the property of the Laplace transform. Okay, let's look at the example 4.3. By applying the linearity property of the Laplace transform, evaluate the Laplace transform of 3 plus 4t squared. Okay, so you need to refer to the property of the Laplace transform in order to solve this question. Okay, let's solve it together. So this will equivalent to Laplace transform of 3 plus Laplace transform. So you have 4. Okay, so you have 4 Laplace transform of t squared. Okay, Laplace transform of t, so you can refer to the formula that I have sent to you through the Google Class. So you can open up the Laplace transform table formula. So Laplace transform of t, so Laplace transform of 3. So if you check the table, this one is a. Okay, ft is equal to a, so you will get a over s. So means that you have 3 over s here. Okay, plus Laplace 4 Laplace transform of t squared. So you look for the t squared, so t power of n. So n factorial s power of n plus 1. So means that you have t is t squared, square is 2. So it's 2 factorial s power of 3. So this is equivalent to 2 factorial means is 2 times 1. Okay, so 2 times 1, so you have 8. So you have 8 over s power of 3. Okay, so it's simple. Now let's look at the second example. Laplace transform of t minus 2 power of 3. Okay, so this is equivalent to Laplace transform of if you factorize it. Okay, let's factorize it first. T minus 2 squared equal to t minus 2 times with t minus 2, right? Yes, what do you get? Yeah, correct. So t squared minus 4t plus 4. Alright, so if t minus 2 power of 3, this means that you need to multiply again the t minus 2. Am I right? So what do you get here? So t power of 3 minus 4t squared plus 4t minus 2t squared plus 8t minus 8. So this is equivalent to t power of 3 minus 6t squared plus 12t minus 8. So this is the answer for the t minus 2 power of 3. So okay, you can substitute in. So this part I write it here. So equivalent to Laplace transform of t power of 3 minus 6t squared plus 12t minus 8. So it's Laplace transform of t power of 3 minus 6 Laplace transform of t power of 2 plus 12 Laplace transform of t minus Laplace transform of 8. Okay, so as I mentioned to you just now, t power of 3 is referred to this formula. Right, is referred to this formula. So you have 3 factorial divided by s power 4 minus 6, 2 factorial s power 2 plus 12, 1 factorial s power of 2 minus 8 over 3. Okay, so you solve it. So 3 factorial is 3 times 2 times 1, so you get 6. Okay, so you have 12 over s squared minus 8 over s. Okay, so also it's simple. Now let's look at another example. Laplace transform of cos squared t. So you cannot directly solve this Laplace transform, so you need to go through identity. Okay, identity. So it's a cos 2t equal to 2 cos squared t minus 1. So cos squared t equal to cos 2t plus 1 divided by 2. Alright, so this is the identity. So Laplace transform of the cos squared t equivalent to half Laplace transform of the cos 2t plus Laplace transform of 1. So equivalent to half for the cos. Okay, let's check for the cos. What do you have? That is s over s squared minus a squared. Okay, s over s squared plus a squared. A squared is 2, so it's 2 squared. Plus is 1 over s. Okay, that's all. Okay, next though, for the next example is a Laplace transform of the sinh square to t. Again, you need to go through this identity first. Identity of the sinh. You change the sinh square to t to cos 4t minus 1 over 2. This one is under the identity table. Okay, so straight away you can have the Laplace transform of the sinh square 2t equivalent to Laplace transform of the cos 4t minus 1 over 2. So this equivalent to half Laplace transform of the cos 4t minus Laplace transform of 1. So this equivalent to half cos 4t, which is, okay, you check again the formula for the cos. It's s over s squared minus a squared. Okay, is s over s squared minus a squared. A squared is 4. So 4 squared minus with 1 over s. Okay, let's go to another example on Laplace transform of sine 2t plus pi over 3. Okay, again you use the identity. Sine A plus B is equal to sine A cos B plus cos A sine B. So sine 2t plus 2 over 3 pi. Okay, you multiply in the 2 here. So you got 2t plus 2 or 2 pi over 3. So this is equivalent to half of the, so negative half. Okay, so you have negative, oh wait, no, it's not negative half. Wait, so equal to sine 2t cos 2 pi over 3 plus cos 2t sine 2 pi over 3. So this is equivalent to what? This is equivalent to sine 2t cos 2 pi over 3, you get negative half plus cos 2t. And sine 2 pi over 3, you get square root of 3 over 2. Okay. Now, this one is just the sine 2t plus 2 pi over 3. But what about the Laplace transform of the sine 2t plus 2 pi over 3? Okay, so you get half of the Laplace transform sine 2t plus square root of 3 over 2 square s over s square plus 2 square. So this part you change from the cos 2t. Okay, so I have the minus here. So it's a minus half 2 over s square plus 2 square plus square root of 3 2. Okay, so I would have this answer. Since this is the same, so I have a square root 3s minus 2 divided by s squared plus 4. Okay, so this is the answer. Okay, then I give you another or last example on the Laplace transform of the 2 exponent minus t minus 1 plus with the exponent t. So this is equivalent to Laplace transform of the 2 exponent negative t exponent. So I separate it. Okay, I separate it plus the exponent t. This is equivalent to 2 exponent is actually is like a constant. Then Laplace transform of the exponent negative t plus with the Laplace transform of the exponent t. So for the exponent t, I have the formula here. Exponent at you will get 1 over s minus a. So if you have exponent minus at, so it's 1 over s plus a. Okay. So again, so I have the 2e. This part is 1 over s plus a. A is 1. For the exponent t, I get 1 over s minus 1. Alright, that's all for the properties of the Laplace transform. Hope you can understand and you practice more. Thank you for watching. See you next class.